Number 5, write the equation with a focus at 2, 3 and directrix y equals -5. What I would do is we can plot first the focus and directrix y equals 5. So 2, 3, so this is our focus. And directrix is at y equals -5. And I will just dotted this. There. So we know that the focus is inside the parabola. So it means that this equation or this parabola will open upwards. So it's a vertical parabola that follows the standard equation x minus h squared equals 4py or y minus k. We use h and k because we know that the vertex is not at the origin. So the vertex will be at h, k. We also know that the focus and the directrix have the same distance to the vertex of the parabola. And the vertex of the parabola is the midpoint between the focus and the directrix. So let's review. Let's find the vertex using the midpoint formula. So the vertex HK is the midpoint of the focus, which is at 2, 3, and the directrix at y equals -5. So if I will just plot this point, then I'll have 2, -5. So let's compute the vertex. So it's going to be at 2. And then the y would be -5, the midpoint formula, plus 3 over 2. So that's 2, -1. So that's the vertex. So 2, -1. There. So if we're gonna graph this, it's going to be opening upward. We also know, we learned that the vertex is p distance to the focus. And also this vertex to the directrix, that's also p. So therefore, p would be equal to 4. We can just count, or we can just use the distance formula. So the distance between the focus and the vertex, so 2 minus 2 squared plus -1 minus 3 squared. So that would be, so this is 0, -1 minus 3 is -4 squared, which is 16. So square root of 16 is 4. So that's the distance, and that's our p. So now that we know the p, so we can just substitute everything that we know in this standard equation. So x minus 2 squared is equal to 4p times 4 times y minus -1. So x minus 2 squared is equal to 16 y plus 1. So this is the answer. Okay, next problem. Determine the equation of the parabola with a focus at 1, -5 and directrix y equals -1. So let's plot first the focus at 1, -5. So this is 1, -5. So this is the focus. And directrix is at y equals -1. Okay. So we know that the focus is inside the parabola. So therefore, this is a vertical parabola that opens downward and follows the standard equation of x minus h squared is equal to 4p y minus k. So let's identify the vertex at hk, and from the graph we know that our h is also equal to 1 because it's collinear with the focus, and our y would be the midpoint of the focus and the directrix -1. So -5 plus -1 over 2. So 1 is equal to -6 over 2. So our k value is -3. So this is our vertex. So let's plot that. 1, -3. So it's here. Okay, let's plot our graph. So opening downward. So from our graph, we'll be able to identify also our P. So our P is the distance between the vertex and the focus. So from here, our P is -2. It's negative because the parabola is opening downwards. So let's substitute everything that we calculated to our standard equation. So x minus 1 squared is equal to 4. P is -2. And then y minus rk -3. So let's simplify. X minus 1 squared is equal to -8 y plus 3. This is our equation. Next problem. Find the coordinates of the vertex and focus. Find the equation of the directrix. Calculate the length of the latus rectum. Find the domain and range given by the equation x minus 1 squared is equal to -4 times the quantity y minus 3 and graph the parabola. So from the given equation, we know that it follows the standard equation x minus 1 squared, x minus h squared is equal to 4py minus k. So we know that this is from x squared is equal to 4py, wherein the vertex of this is at the origin or 0, 0. But in this case, the vertex is at h k. So since our equation is quantity x minus 1 squared is equal to negative 4 y minus 3, therefore we can identify the coordinates of the vertex. So h is 1 and k is 3. Okay? From this equation also, x squared, we'll know that the parabola is vertical that may open upward or downward. And if the vertex at the origin, if p is positive, then the parabola opens upward. If p is negative, the parabola opens downward. In our given problem, 4p is given, so we can solve for the p. So 4p is equal to negative 4. So p is equal to negative 1. So p is negative, so therefore this graph is opening downward. So downward. Now going back to the parabola when the vertex is at origin, our focus is at point 0p. Since our given equation of the parabola has a vertex of 1, 3, so now the focus here, will also shift at h and k plus p. So therefore, the focus would be at 1, k is 3 plus negative 1. So the focus is at 1, 2. Also, the directrix, we can find the equation of the directrix. So if the vertex at the origin, the directrix would be equal to y equals negative p. So in this case, at hk, the directrix would be y is equal to k minus p. So k is 3 minus negative 1 equals 4. So therefore, the equation of directrix is y equals 4. Before we graph, let's also calculate the length of the latus rectum. So since this is the length, let's take the absolute value. So the length of the latus rectum is equal to 4p. We know that p is equal to negative 1, so absolute value. So 4 times negative 1. So it's 4. So that's the length of our latus rectum. So it means it's 2 units from each side of the vertex. Okay, so now let's plot or sketch the graph. So let's start with our vertex 1, 3. This is our vertex. The focus is at 1, 2. This one. Equation of directrix, y equals 4. So this. So y equals 4. Now let's sketch our graph. Okay. So let us now identify our range and domain. So for our domain, if we're going to follow the graph, so this will go all the way up to negative infinity, and this one also will go all the way to positive infinity. So therefore, our domain is from negative infinity to positive infinity. And for the range, the highest point is at y equals 3. So 3 up to, so it goes downwards, all the way down. So up to negative infinity. So that's the value of our range.